Okay, yeah, go ahead, do this question, relative rates question, okay? The volume of a cube is increasing at a constant rate of 745. And at the instant when the volume of the cube is 676 cubic meters, what is the rate of change of the surface area of the cube?
I don't even know the equation for the surface area. Oh, it's just 6. No, 1, 2, 3, 4, 5, 6.
Yeah.
6 times the sides, right?
Yeah. The
Okay.
volume, okay. The volume of the cube is increasing, so dV over dt is positive 745, right? And at the instant, the volume, so the volume equals to 676.
Yeah.
Yeah. What is the rate of change of the surface area? The surface area is 6 times a squared, right?
I already have that.
Yeah, and a cube is 676.
I'm just using a different letter than you. I just put it as X.
Yeah.
Whatever.
Yeah, X. I think X is even better. Let's use X.
I just use X because I use X for one side. So if I do the volume, it's X cubed.
Yeah. Yeah, that makes sense. So you want to do the cubic root of 676 to see how much is that guy.
I don't know what 676 is, the cubic root of it.
Yeah, we have to use calculator, okay?
Yeah. But they don't even let you use a calculator on the quiz, on the test. So that's why they did not include any related rates problems.
No, this question 676 is not really an integer for the cubic root. You have to use a calculator, okay?
Yeah, no, I know. I'm just saying they don't give us a calculator, which is they don't give us related rates problems on our test.
All right, let's do something, okay? Yeah, so the side is 8.776.
Okay.
And then the a equals to 6 times x squared. So dA over dt
is just 12x. Yeah.
Equals 12x times dx over dt, right?
Yeah.
Yes. But we don't have dx over dt, do we? We don't.
No.
So we have to do one more step.
Okay.
We have to say v is x cubed. Then dv over dt equals to 3x
squared times dx dt.
And dx over dt. Yes? And the dx over dt is dv over dt over 3x squared, right?
Yeah.
Okay. Yeah, we do the simplification to help us, okay? Now, 12 and 3 can
that turns
cancel.
into 4.
So that's 4. Yeah. Then this x and this x canceled, you know? Okay. So this gives us 4 times dv over dt over x. All right?
Okay.
Yeah, if we plug into calculator, this is 4 times 745 divided by the x value. So this is equals to 339.547. All right?
Okay.
Okay. Now, this question is not so that hard. Let me pull a question. I want you to do this guy. Go ahead and do the work on this question. Okay. You have to be careful for this question. Yeah, you want to convert. They told you the rate of change.
I already know the rate of change for the radius. Yeah, I know. yeah. Let me just pull up a calculator for a second.
Okay.
I don't want to do this large number calculation in my head. Seven, eight. I think I got it.
Mm-hmm. How much?
First off. Okay, hold on, let me see. Hold on. Sphere says it's decreasing. I actually did increasing. Give me a second. Okay, -2.
That's it.
-2, -8. Where else do I use this? Okay. -1,700 and -1,706.19 something.
Yeah, correct.
Okay, there we go. See, I did it. I did a related rates problem. I'm so happy.
Yes. Let me ask you one more question about relative rates. Okay.
Yeah. Just let me get on another page.
Let's go do this one.
Oh my god, it's a cone. Seriously, I almost didn't catch my mistake on that one. I said decreasing, but I did increasing.
Mm.
It
Yeah,
was
go
just
ahead, do this one.
okay.
You can use your calculator, all right?
I'm just working out. I just had something to do with product rule, and when I had to derive something, just give me a second.
Okay.
I'm just plugging in values. I'm actually already done with the problem, almost.
All right. If you can do this guy correct, I don't worry about your related rates question.
Yeah, it just, there's a lot of variables to solve for, so just give me a
Right.
second. Hold on. Can you go back up to the problem? I need to see the whole problem.
Sure.
Yeah. What is it supposed to be? Negative 3.5 something?
Nope. Let's do this one together. This question is a little bit tough. Okay.
That's what I'm saying. It says the volume stays constant, so I set it to 0.
No, the change of volume is 0. Okay.
Yeah, that's what I'm saying. That's what I'm saying.
Yeah.
It said dV/dt to 0.
Yeah. Okay. Let's do it together. V equals to 1/3 times pi r squared times h.
Okay.
And they told you the dh over dt, your height is decreasing
Yep.
at -8. Okay. So velocity volume is 258. Okay.
Oh.
Yeah. At this moment, your volume is 258.
Yeah, I wrote
And your
that down.
radius is 6.
Yep, I
Now,
also
based
have
on
them.
this, you want to calculate your h. Did you get your h value?
Okay, I see where I messed up. I didn't. I tried calculating h a different way. It was really weird. Hold on, let me see what happened. 136.
Okay, you can double check your h.
1/3 pi r squared h. That's 1/3 pi times 36 times 8. Volume is 258.
Mm-hmm.
Okay, hold on. 258 equals 12. Something. 258 times 3. over 12 pi. So I have probably the unsimplified version of this. I had 258 over 12 pi.
Yeah, you see 258 is divisible by 3, so you want to simplify. Those numbers are too big. You want
Oh,
to
no. It doesn't matter because I just plugged into the calculator though. So I have the same value for h. Yeah, I got the h. I got every single value correct except for drdt.
Okay.
I even did your dvdt correct. My chain rule is all correct. Like I saw it.
Okay. So now can you put it back into your answer to see if your final answer is same as my answer?
Hold on, give me a second. I just need to see what you did that might be different from me. Can you go back to the question? Like you zoom out because I can't see the question. Oh, okay, I see. Let me explain to you why I got a different answer from you.
Sure.
I put what was it called? I put a positive 8 instead of a negative 8 when plugging the equation in.
Oh.
Yeah, so I got the exact same answer from you, except see, here's where I mess up. I mess up when they say increasing or decreasing. I always think it's increasing, so I never think it's decreasing. But
Yeah,
everything else, because I was thinking, why did I get a different answer from you when I got the exact same equations as you?
Okay.
Yeah, okay. So
all right.
It was just me misreading the question, but
yeah, this is the most complete question.
Okay, but I almost got it right. All
right.
Okay, I got all of your equations except for that one.
All right. Other question is too easy. I will move on. Okay.
Oh, yo, this is the problem that I wrote my little project from last week on. I got 100 on that. It was easy.
Oh, okay. Congratulations. That's good. Now let's do. Did you finish the inverse? Did your teacher teach you the inverse function derivative?
No, ma'am. I have not touched it so far.
All right. That's a hard topic. I need to teach you, okay?
Oh. Does this have some like really complicated?
Yes. Okay. First, let's see the inverse function first, okay? This is your x, and then you have fx.
Yep.
X, fx. If you want to write down your inverse function, you are going to switch your x and y, okay?
Okay.
Yeah. So you switch your x column, y column, you becomes to your f inverse x.
Yep.
If you want to get the g inverse, then you switch your x and y also. Right?
Yeah. I remember when we did this stuff for the solving for logs and stuff, whatever it was.
Yeah. Mm-hmm. Yeah. So this is something for algebra 2. I'm not going to explain. All right.
Okay.
Well, I'm going to jump to the major part for today. If you have f of f inverse x, that is going to equals to x, right?
Yeah. Okay.
Because
I remember that from algebra 2 also.
Yeah.
The question was like prove that these two are inverses, so we plug them into each other, and which is supposed to end up with x.
You see here, this equals to this, right?
Yes.
Right. Then you put f on this left, then you get x to the other side.
Yeah. That's what I was saying about the algebra 2 thing. We were asked. They give us two functions. They say prove that these two functions are inverse of each other.
Okay.
I remember those questions.
Now, we want to do the derivative of the inverse function. Look at this. I want to do this guy derivative. I have to use a chain rule, right?
Yeah.
So that means I'm going to do f prime of this guy times this guy derivative, right?
Yeah.
Equals to 1. So this guy is going to equals to 1 divided by this whole thing. That makes sense?
Yep.
Okay. So this is one version of writing down the inverse function formula. And there's another version I'm going to also introduce. If fx and the gx are inverse, yeah, if these two are inverse to each other, then gx is f inverse, yes?
Yeah.
Okay. Gx derivative, you can also write down. The reason I like to write down this way because this will look simple.
Okay.
G prime x is 1 over, it's going to be 1 over f
prime of g of x.
f prime of gx. Okay.
Yep.
This definitely looks simple than this guy, right?
I mean, yeah, but you read it the same way. It still has the same meaning. It's no different.
Okay. Now let's do the first example. Okay.
Yeah.
Yeah, I'm going to show you how I do this.
Okay.
So I was given fx equals to 4x minus 3.
Yep.
And f prime at x equals to 2 is equals to 4. Well, I don't need this. I know that the derivative is 4, all right? Okay.
Yep.
So now let's get f inverse of phi derivative. Okay?
Okay.
Yes? So as this formula, that's the formula we did just now.
Yep.
That's equals to 1 over f prime, then f inverse of phi.
Yeah, the answer should just be 1/4, right?
So f inverse of phi is how much?
Hold on.
F inverse of phi, you are
phi.
going to make your y equals to phi and get your x. Yes?
Oh, okay. Okay, right. And we're just solving for that. Okay.
So x equals to 2.
Yeah.
So that means this guy is 1 over f prime at 2.
F prime of 2 is 1/4. Yeah, I said 1/4 in the beginning, but that's not the reason I said it. The reason I said 1/4 in the beginning is because f prime of x will always equal 4 for every x value you plug in.
Yes.
So I didn't even have to do this to find the answer.
Right.
But they want us to show work, so whatever.
Yeah. Mm-hmm. Now let's do example 3. Okay.
Am I forgetting my pencil somewhere? Where did it go? Hold on.
Let's look at example 3.
Okay. Where g of x is the inverse of f of x. Oh. Hold on, give me a second. This is like gotta give me time to process this.
You can do this by yourself, all right?
Oh, yeah, give me a second. I need to get that formula again. G of equal to 1 over f prime of g of x.
Mm-hmm.
Okay.
This is one of the hard part for the derivative,
So
okay?
g prime of -1 is equal to 1 over f prime of g of x. How am I supposed to solve for g prime of -1 if I don't even know what g of x is? Because you need to plug g of x into f prime of, yeah.
Hey, you look. Let me explain. Fx and gx are inverse.
I know.
So if x is 5, yes?
Yeah.
Then gx is 2. Yeah. So this guy come back, right?
Oh, okay. So I just flip x and g of x, okay? Okay. Yeah, all right. So I already know this then. That means g of x is just, oh, okay. Then I can do f prime of 2. F prime of 2 is
It's 0,
5.
right?
No. F prime of 2 is f prime of 2. Yeah, it's 0. Okay. So
So
it's 1 over 0 is undefined.
Undefined, or you can say infinity. Okay.
Okay. Well, I don't think they will take. I think they want us to say undefined. They never tell us to say infinity. Not until we learn like indeterminates and stuff.
Okay.
Yeah. Okay. 1 over f prime of 3 is -4. 1 over -4. Okay. Okay. That makes a lot more sense now. I got you.
Okay.
See, I didn't know you were gonna flip x and g of x, but whatever.
Okay. Now you can do g prime of 3. All right.
You want me to do g prime of 3?
Yes.
Okay. Well, I literally just did g prime of 3 for you. Hold on. Oh, well, I just said I literally just did g prime of 3. So if you want me to do g prime of like 2 or something, I can do that. Wait, no, we did all of them. Hold on. Oh, okay, no. I did for you g prime of 2 and g prime of 3, so I can do you g prime of -1 because that's the actual one that I haven't solved by myself yet.
Okay.
Okay, yeah. Okay, that's 1 over f prime of g of x is -1. F prime of negative is 6. Okay. Same answer, 1 over 6.
Makes sense now?
Yeah, only the flipping over part, yeah. That makes sense.
All right. Go. Get this by yourself.
Huh. F of x equals this. Oh.
When your school teach this part, you will feel really happy that I teach you already, okay?
Yep. Let's hope I can feel happy now. Real question. Okay, hold on. F prime of x is 12 x squared plus 5. Hold on. G prime. Wait, can you just go up to that chart from before? I just want to see something. All right. Okay. G. Okay, real question. If they don't give me the value of x, how am I supposed to solve for g of x?
Look, they are asking you for g prime of -9. So you
Yeah,
are
I
going
know,
to make
but
your
g.
y equals to -9 and find your x.
Oh. Okay.
You will need to solve that polynomial
X. Okay,
equation.
that's fine. I can do that myself, but you really don't know unless they tell you. But I guess okay, negative. G prime of x is x equals negative. Well, that just turned very complicated. Okay. What happens if I get 3 values for x? Real question.
No, just one.
Am I supposed to just get 1 because solving this?
Yeah, don't worry. You will only get one real solution.
So how do I know which of the other 2 are fake?
Hey, you saw one. You found out one. The other two you will find out is imaginary.
Yeah, they are. They are. They come in pairs. It's a plus or minus, and then there's one real value.
Yeah, you use that one real value.
Okay. So it's just -9 then, I guess. Only. Da, 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 da. I can't seem to. Okay. I guess I can work with that. Oh. Am I supposed to flip the x and y for f of x to find what g of x is, and that can plug it in?
Yeah. Of course,
Okay.
you need to make -9 equals to the y and find out your x.
Well, no, that's not what I was talking about. I was talking about just flipping x and y. So like x equals 4y cubed plus 5y. And then I can solve for y. So then I get the y equals, and then I have an x equation. So I can plug that in for g of x, because I already have the rest of it. Y, 4y squared plus 5 equals x. Like I said, I already have the imaginary and the real value. I just need to figure out how to get this inverse. That's it.
Okay.
The problem is algebra is kind of weird. I can't figure out how to get one of these out. It's a cubic. How am I supposed to solve this? It's a cubic. And
No, look at what I did.
No. I told you I have the factoring down. I need to find G of. Oh wait, you already found it. Oh, okay. I didn't realize you just got the value already. I have the value, but I didn't think it was G of X or whatever. -1 squared is just 12 plus 5 is 1 over 17. Oh my god.
1 over 17. 1 over 17.
Yes, I know. I just got confused on what G of X is. Because, like, this is just confusing. Like, I'm flipping a bunch of things around.
Okay. Now let's do next question.
My brain is actually going to die today. Thank you very much.
You'll be really happy that we do this, okay?
I have to use a calculator for this.
Yes.
Oh, that also means I don't have to factor by hand anymore. I just factor with the calculator.
Mm-hmm.
Yeah, there's no way I'm factoring an x to the 7th equation by hand. X to the 7 minus x squared plus x minus 5.
What do you mean minus 9? Minus 8.
What? What are you talking about?
5 minus 3 is 8. Minus 8. You say something minus 9.
No, I didn't say that. I'm just typing it in right now. I'm trying to factor it.
Why you want to factor? You're just graphing and get your x value. Why you want to factor?
You didn't tell me that. Not really my thing. I was thinking I had to do the same thing as before. Like solving for f prime of x and that kind of stuff. Whatever it was. Whatever I said was not the answer, so don't pay attention to it. So I'm just supposed to graph this, and then I can just go into the graph and type f inverse, and then I can just find it. That's it. I don't have to do anything myself. Really? Okay. Seems easy enough. Hey, nobody told me how to do this, so don't expect me to go perfect.
I'm teaching right now. Don't say that.
No, I'm saying, like, I didn't know you could just graph it. Like, who's here to tell me just go graph it? I tried to solve it by hand.
Did you see this?
No, I didn't. I mean,
don't argue. Just do it.
Accurate to 30 decimal place. Okay, this thing gives you every single instruction, I guess. Cool.
Yeah, this one is a good one. Okay, they give you every single steps. Now let's move on to doing derivative of the exponential and the logarithm. Okay.
Oh.
I even derived this formula for you before.
Which
okay.
one? All of them?
Yeah. Because
Okay.
e to the power x derivative is e to the power x, right?
Yeah.
Okay. Now, a to the power x is going to, we can do this guy. We can do e to the power of ln of a to the power x. Yes?
Uh-huh.
That's equal, right?
Yeah, I know. E and the ln cancel,
Okay.
I know.
A to the power of log ax equals to x, you know?
Yep.
So this e, so that's equal. And based on this guy, this is e to the power x times ln a, right?
Yep.
And a to the power x derivative is going to use our chain rule. All right, let's do this. This guy is use chain rule. E to the power of something is just copy down the whole package. And then your x has a coefficient of ln a, so that times ln of a. Okay?
Yeah.
Now look at this. This guy is just a to the power x. So that's just as ln a times a to the power x. Does that make sense?
Yeah, hold on. Okay, I see what you did. So the x goes away when you take the derivative. So ln a is just a constant?
Mm-hmm. It's
okay.
a coefficient. All right? Yeah. Now, if you don't use x, but to the power u, okay?
What's
this
the
one,
difference?
You are going to do same thing as you do the chain rule. This guy, you first take out ln a,
Okay.
and then a to the power u, and then du over dx, right?
So du. Okay. Does this have anything to do with like what we're gonna learn in the future about u substitution or whatever?
No, this is just a chain rule.
This is, I know, I'm just saying, I don't know why they're using two variables though.
This just means your exponent is not x, it's
It's a different, like it could be like t or something, like whatever.
Yeah.
Okay.
Yeah. Now let's do this guy. D of log ax over dx. Yes. So you are going to do log ax. I do show you how to do the ln x derivative, you know? I want to do this guy derivative. So this guy, I can rewrite as e to the power x, e to the power y equals to x. Right?
Yep.
And then you do the derivative for both sides. So this guy derivative is e to the power y, and then times
dy dx, right? I
dy
mean,
over dx.
and then equals 1.
Then equals to 1. So dy over dx equals to 1 over e to the power y.
Okay.
Then this guy is 1 over x. Okay.
Okay.
And log ax is going to equals to ln x over ln a.
Okay. Power was the base change?
Yes, base
okay.
change rule. And then you want to do this guy derivative. So log ax.
Oh, I guess do product rule. That's ugly.
Yeah. So it's going to be 1 over ln a, and then times 1 over x.
Yeah.
Okay. Does that make sense?
Yeah.
Okay. Now let's do number 4. Number 4 is the same. Yeah. You take out the ln a in front. You take u in front, and then you do du over dx.
So basically, 2 and 4 are the same as 1 and 3, except you have to add the du dx at the end. That's it.
Right.
Okay.
Yeah. So like this, for example, this one is not just x, it's 3x. So you want to do this way. Basically, it's just a chain rule, right?
Yeah. But you just memorize these afterwards and you're good to go.
Yeah. Now let's do. Let's do this one.
Y equals 3 to the x, that one? Y equals, okay.
So this guy is
a to the x, that kind of thing.
ln 3 times 3 to the power x, right?
Yeah.
Okay. And this guy is ln 4
times 4 to the
times 4 to the power 3x, and then times 3.
Chain rules, so fun. Oh man.
Okay. All right.
Hold on. This is because you're using that
Using
U.
this guy.
Yeah, that's what I thought.
Okay.
Wait, so apparently 3x does not count as x, so I guess it's just so anything that's not x, even if a coefficient in the front, you have to start using the chain rule for this.
Yeah.
Okay.
Now let's do C.
Huh? 5 to the x squared. Okay,
Yeah,
interesting.
you take care of this as an exponential function first. So of course you do ln 5 first.
Yeah,
and
times
then 5 to the power of x squared.
Times 2x.
And then x squared is 2x.
Okay, yeah. Okay, I understand.
Okay.
So the other one would be ln 5 times 5 to the 3 minus x squared, and then times negative 2x. Right?
Mm-hmm.
Okay, I got it.
I will learn a lot of things today. Okay.
Yeah, but the inverse thing hurts my head a lot more than this. This is a little better, you know. Derivative other bases is a lot better.
Okay. Now we want to use that formula. Okay.
Yeah.
That guy. Now y prime is 1 over ln 5 and then x. Okay.
Okay.
Listen. That's different. Okay. This guy is not equals to this guy. They are totally different. All right.
Yeah, I know.
This is by itself. Okay.
Okay.
Now let's do B.
Oh.
Y prime is
that's gonna be the chain rule right there.
1 over ln 3
times sine
times
x, then times cosine
1
x.
over sine x
Yeah.
times cosine
x. Yep, I know.
Okay.
That's where the chain rule comes in. Okay. So I'm basically just following a formula for this, but then I add the chain rule at the end if it's not x.
Yeah. I want to teach about this one. Okay. Yeah, I think you can handle those questions.
Yeah.
Let's do this. Find an equation of the tangent line of fx equals to 6 to the power x, where x equals to 2. So you want to find the tangent line, for sure you have to get the derivative.
Yes.
So f prime x is ln 6 times 6 to the power x.
Yeah.
When x equals to 2, f prime of 2 equals to ln 6 times 36.
Okay.
At x equals to 2, f2 equals to 36.
Okay.
So you are going to have y minus 36 equals to ln 6 times 36 times x minus 2.
Y minus 36. Okay, that's y equal. And then your f prime of 2 is your slope. So this is just point slope form.
Yes,
Okay.
point slope format. Very important format.
And then your x is 2, so you just do x minus 2. So this is going to give you your tangent line equation, right?
Yes.
Okay. So you already have it. That's the equation. All right.
Yeah.
Oh.
Let's do this D also. Okay. Let's finish also this one.
Okay.
So y prime is going to be 1 over
ln 2
and then
times
1 over cubic root of 2x plus 1.
Yeah,
Yes.
and then you have to power rule, chain rule
we do
it.
this guy. We do
chain.
1/3.
Yeah.
1/3 2x plus 1 to the power of 1/3 minus 1 is -2/3.
Then you have to multiply by 2 or something.
Yeah.
Yeah.
Okay. That makes sense?
Yeah. Yeah, it's funny how the chain rule can repeat itself like 2 times. That's
Yeah. Chain of chain, okay?
Yeah, that's what I'm saying. It's
This guy is going to be, this log means base is 10, right?
Yeah. Okay, so it's ln
If
10.
they didn't write anything, by default, the base is 10.
Okay. Yeah. So that's 1 over natural log of 10.
So that's 1 over ln 10. And
times 1 over
1
x
over
plus
x plus 3 to the power
y.
x. And then x derivative is 1.
Yep.
3x derivative is ln 3
times 3
times
to the x.
3 to the power x.
Yeah.
All right. That makes sense?
Yeah, these come out so complicated though. You can't simplify them very much after they come out.
Yeah. And next question is just plug in. Yeah.
Really?
Yeah. After T hour, after 0 hour, 2 hour, 8 hour, they ask you WT equals how much?
What is the limit as t approaches infinity?
So you can tell when T go to infinity, e to the power of negative 0.4t is going to 0, right?
Oh, yeah, because it's going towards negative infinity up there.
Yeah. So WT is going to 1.3 over 1.
Wait, so 1 plus 0.
Yeah, that's 1.
Okay.
You can definitely do this. W0 equals to how much? 1.3 over 2, right?
Yes.
Hold on. 1.3 over 1.3 over 1 plus 0.3. Yes?
Okay.
That's 1.
Yeah.
T equals 0, that's 1. So that's 1. W2, okay. And then W8, you have to plug in this into your calculator, all right?
Oh.
Yeah. Okay, but your limit is going to be approach to 1.3.
So the limits thing is like something we learned at the beginning of the year. This is just evaluating limits to infinity.
Right.
Okay.
All right, I'm going to give you this, okay?
Okay.
That's a really good worksheet.
So are we still 6 weeks ahead of our school? Or are we just like a few weeks ahead? Because I want to know when this is coming.
Yeah. 4 to 5 weeks. Yeah.
Okay.
All right. You please check the notes, okay?
Yeah.
All right. That's it.